This experiment is called the Tie-Dye Milk Lab, and basically it allows elementary school students to learn about different properties of liquid while also having fun and being a bit creative. So thank you for watching and enjoy the video. So you're going to need a shallow plate. Ideally it would be clear, but this is not an ideal world, so it's not. And then need some dish soap. So food coloring, I think you can have up to 4 colors, or honestly as many as you want, but I just got blue. You're gonna need some milk or a milk alternative, and you're gonna need a Q-tip or a toothpick. Okay, so first things first, you're going to add just enough milk to cover the bottom of your dish. So let's see, maybe a little bit more. Okay, I think that's enough. And then you're gonna put some dots of the food dye around, and this food dye is not open, so that's fun. Alright, so we've already put just enough, oh cute, there's a hair, just enough milk to cover the bottom of the shallow dish, and now we're gonna add some dots of food dye. Oh, that was a lot. Okay, I'll probably be fine. Okay, and now you're gonna want to take your little Q-tip and put some dish soap on it. Riley Massey from Root, so please give her a hate. Alright, now let's head to this. Alright, so I'm just gonna put this here. Ooh, what's happening, guys? Kinda cool, isn't it? Huh? So right now I'll just be talking about why this experiment works. So the reason the food dye sits on top of the milk in the first place is because it is a less dense liquid than milk. And so when you touch the milk and food dye with a soapy Q-tip, the surface tension of the milk reduces. This is because the soap molecules are bipolar. So they have one end which is hydrophilic, and this end dissolves upon touching the milk and food dye. The other end is hydrophobic, and so this end attaches to the milk fat molecules when they interact, which weakens the bonds that hold together the fat molecules of the milk. The milk which was not touched by the soap has a higher surface tension and moves away from the soapy milk, taking the dye with it. And so when you continue to move around this soapy Q-tip, you essentially allow the soap molecules to chase the fat milk molecules, which are desperately trying to get away. So like that's kind of a way you could explain it to younger kids if you're doing this experiment with them. Something else which is fairly interesting is that the higher fat percentage milk you use, the better this experiment works. So while you can use any type of milk from 1% to whole, generally the more fat that's in the milk, the more impressive the results will be. But like in my case, I think we used almond milk. So that's actually a substitute, and I think that it still worked pretty well. So yeah. So a liquid's surface tension is caused by the attraction of the particles in the surface layer. And another term for this attraction of liquid particles would be called cohesion. And so in the experiment's case, it would be displaying the cohesion of milk molecules, but in the case of this visual, this is displaying water cohesion, which is very strong because of the properties of water. And so you can see water is so strong that it allows even a small bug to float on it. And so surface tension also tends to minimize a liquid's surface area. So some important properties of soap which causes the experiment to work would be the fact that it is bipolar. So one side is hydrophobic, which can simply be defined as meaning water hating. So molecules which are repelled to water and refuse to mix with it typically. And hydrophilic molecules are basically the opposite. They are water loving, and so they are attracted to water and attempt to mix with it.